Most people misunderstand Einstein's equation, E equals mc², due to a common misconception. They think it only applies when mass is converted into energy, like in nuclear bombs or the fusion that powers the sun, or the reverse, when energy transforms into mass, like in high-energy particle collisions. But this same equation actually describes energy processes everywhere, from quantum interactions to boiling water, phone batteries and chemical reactions, to biological processes like photosynthesis, stars, black holes, and even the evolution of the cosmos. And here's the deeper truth. Every time energy is exchanged, when something heats up, cools down, or stores energy, there's also a corresponding change in mass. Even if it's incredibly small, that shift is measurable and real. Absorbing energy slightly increases mass. Releasing energy slightly decreases it. That energy shift has a mass equivalent, calculated using this equation. Let's start at the atomic level. When an atom absorbs energy in the form of a photon, a particle of light, an electron jumps to a higher energy level. The electron's mass doesn't change, but the atom's total mass increases because the system now contains more energy. A photon of just a few electron volts adds about 1.8 times 10 to the negative 35th kilograms to the atom's mass. When the atom emits that photon, the energy is released, and the atom's mass drops by exactly that amount. That's not just theory, it's experimentally confirmed. It's a perfect example of how E equals mc² applies far beyond explosions and fusion, even to something as subtle as a single atom absorbing and emitting light. Now zoom out to chemical reactions. When molecules interact, bonds form or break, and energy is exchanged. If a reaction releases energy, like burning fuel, the final products have slightly less mass than the original molecules. If energy is absorbed, like when charging a battery, the system gains mass. The change is tiny, but real. That's why a fully charged battery actually weighs more than a drained one. It's not a metaphor, it's E equals mc² in action. The same principle applies to heat. Heat a copper object, and you're adding internal energy, which increases its mass. For example, a 1 kilogram copper block heated from 25 degrees Celsius to 1000 degrees Celsius holds about 375,000 joules more energy than at room temperature. That translates to roughly 4.2 times 10 to the minus 12 kilograms of added mass. Cool it down, and that mass is gone with the heat. In biology, the same logic holds. When a plant absorbs sunlight during photosynthesis, it stores energy in the form of glucose, and with that, it gains mass. It's not just turning light into sugar, it's turning energy into matter. The gain in mass is small, but absolutely real. That's E equals mc² at work in every green leaf. Now let's scale up to the cosmos. Neutron stars, the densest objects in the universe outside black holes, slowly lose energy by radiating heat and magnetic fields into space. And because of mass-energy equivalence, that energy loss corresponds to a tiny decrease in mass. This holds true for black holes as well, whether through Hawking radiation or when infalling matter emits X-rays. Energy, and therefore mass, is lost. Einstein didn't just give us a formula, he gave us a new way to see the universe. So next time you see E equals mc², don't just think of bombs or stars. Think of your phone, your body, your coffee cup. This isn't just physics. This is the operating system of the universe.